follows the path what we have shown in the diagram, that any object which is thrown into space, we can call it as projectile. But this is having a lot of application in the sports as well as defense. In general, you can discuss many things on the basis of this. I think already in the theory class you have discussed. So any object which is thrown into space with certain angle with the horizontal surface, that the angle is theta, that particle goes up. While going up, it will move with a certain velocity. That velocity we can resolve into two components. One is horizontal component u cos theta. Another one is vertical component u sin theta. So this projection angle, depending on the angle of projection, this body, how long it will be there in here, that you call it as time of flight, and then how much is the maximum height it reaches, that you call it as maximum height, and the total distance it covers in the horizontal direction, that we call it as horizontal range. These are the main three things. And of course, you might have derived in the theory class the path. It looks like an path traveled by the particle you are representing by an equation ax plus bx square. I think this is, you are familiar. That if you want to derive, you can make use of s is equal to ut plus half ad square. From that equation, you can show this path of the projectile is a parabola. Then our main aim is we have to find what is the maximum height. The maximum height in the diagram it is shown is OA. That is the path which goes from horizontal. How much is that distance? Maximum height from the horizontal. That is an indicated in this blue color arrow mark. That is what you call is maximum height. And OB, the distance what is shown. This is the horizontal range. What is this projectile covers in during the time interval of time of flight, we call this time of flight, horizontal range, and the maximum height. These are the main three things we can calculate. Based on this angle of projections, you can see the range. Maybe for a pair of angles it remains same, that you can see with the 30-degree and 60-degree, with the combination of 15 degrees and 75 degrees, 40 degrees and 50 degrees, that you can verify experimentally also. This velocity of the particle which is moving in the upward direction keeps varying with the angle. That is why it is horizontal angle cos theta, vertical angle it is u sin theta. When it comes to maximum, the final velocity, we say vertical direction only it will be zero, but horizontal direction it will not be zero unless it reaches this horizontal surface. It will move continuously with certain velocity. For this, we have to derive equations for maximum height. So based on this vector diagram, and it is clearly shown this velocity, how it is vertical component only at the point y, uy will be equal to 0. Otherwise, all the place you have the horizontal velocity with respect to cos theta, you can see. So this variation, based on this, you can derive expression of maximum height. When the particle reaches the maximum height, say capital H, at this particular point, the vertical component of the velocity, as I have shown in the previous diagram, it is 0. Then making use of this 2as, your v will be 0, final velocity at the maximum point, and acceleration a will be taken as equal to minus g, because minus g this is because the particle is moving in a direction, upward direction, against the acceleration due to gravity. The acceleration due to gravity will be in the downward direction. particle is moving in the upward direction. Therefore, the acceleration of the particle is taken as a is equal to minus of g, and s is the distance traveled by the particle, that s is replaced by h. And your initial velocity is replaced by u sine theta. Final velocity v is 0. A plus 2a is minus g. That's why it is minus of 2, that is maximum height attained by the particle when it is moving in the upward direction. Therefore, that equation we can simplify. This is 2gh is equal to u square sine square theta, or the maximum height attained by the projectile is obtained by using h is equal to u square sine square theta by 2g. Then how much is the time of flight it has taken? To calculate that, we can use another, again, basic simple equations of motion. You have, I think, all these three equations you are well familiar. V is equal to u plus at. First basic equation. Second one is v square minus u square is equal to 2as. That also you know. And s is equal to ut plus of at square. These are the three equations what we use, basic equations. So based on that first equation, your velocity v is equal to u plus at. That is simple equation, basic equation. When the particle time of flight means we are taking only from initial point 2 to reach the maximum height. The time taken from the initial point to the maximum height, that is what you call is time of ascent. That is growing, it is going in an upward direction. When it reaches maximum, we have come across this vertical component of the velocity is 0. Final velocity will be 0. Therefore, your initial velocity is u sine theta. Again, a is equal to minus g, that is acceleration due to gravity, and the time t. So therefore, expression for t, if you calculate time for this particle or projectile to reach the maximum height, is given by t is equal to u sine theta by g. This we are getting from the simple equation v is equal to u plus at. Only thing we are making substitutions. That is final velocity is 0. Initial velocity is u sine theta in the vertical direction. Familiar that time of ascent will be equal to time of descent. The particle which is moving in the upward direction where it reaches maximum height, that is what you call is time of ascent. From that point to again to come back to the ground horizontal surface, that will be equal. Both time of ascent will be exactly equal to time of descent. Therefore, time of flight will be equal to 2 times of the t what we have derived. T is equal to u sine theta by g. Therefore, the time of flight t will be equal to 2u sine theta by g. That is the second important thing aspect, or what we have to calculate using projectile. Then the third one is horizontal range. This is the horizontal range is the total distance traveled by the particle or a projectile along the horizontal. The distance covered by the projectile with the horizontal direction or along this ground, how much it can move or cover the distance, total distance will be obtained, or what you call is range, it can be obtained by using the relation r range is equal to horizontal component of velocity into time of flight. The horizontal component of velocity is, you know, that velocity we have split in the beginning itself two components. One is vertical component u sine theta, horizontal component is u cos theta. Therefore, horizontal component of velocity is u cos theta into time of flight is 2u sine theta by g. This you know, we can write it as r is equal to u square 2 sine theta into cos theta by g. Another trigonometric relations you all familiar. I think this is one of the standard relation. Sine 2 theta can be written as 2 sine theta into cos theta. We have this 2 sine theta into cos theta that we can replace by sine 2 theta. Sine 2 theta is equal to 2 sine theta into cos theta. Therefore, based on this, sine 2 theta that will be equal to 2 sine theta into cos theta. So we can calculate this horizontal range. I think that's what I said here is the horizontal range. What will be the maximum value? How we can think of it based on your mathematical relation. The maximum range covered by the projectile mainly depends on the angle of projection. So the maximum value of r we can get from this u square sine 2 theta by t. We know sine theta value. 2 theta value maximum is for 90 degrees. Sine 90 is 1 and you know sine 0 is 0. It varies from 0 degree. That's why the range is keep varying from 0 to 90 degree. But in between you have complement angles like both the angles will give theoretically the same value. When you are doing experimentally, there may be a small variation that you can verify. So this depends on 2 theta. Theta means that is sine 2 theta value that will be 90 degree maximum. Therefore, theta, if you take 90, 2 theta is equal to 90 means theta will be 45 degree. Therefore, if you put sine 45, that means 45 theta, 2 theta 90, sine 90 is 1, then your maximum range of the projectile depends on sine 2 theta is equal to 1. Therefore, it is u square by g. This is the maximum range. So, any particle, if you want to throw into space and if it has to cover maximum range, then it is better to throw at an angle of 45 degree. This they make use of in sports very well. Javelin throw, shot put, disc throw, like this. Many people practice based on this idea. That is the maximum application. And again, the missiles firing, that also in defense, they will make use of this principle. Anyhow, that is your maximum range and horizontal, that is horizontal distance what it covered, then time of flight and maximum height. These three things we have to verify using your simulation part. For that, I want to give little more here. You can see if you want to verify your range. Both are almost having the same horizontal distance. That's why 75 and 15 degrees, both the angles. That is according to your equation, sine 2 theta. So 2 theta value, if you put 15, 15 into 230. If you put 75, 2 theta means it is 150. Sine 180 minus 150, again it will be sine theta. Sine 180 minus theta is sine theta. Therefore, sine 180 minus 150, that is 275. 2 into 75 is 150. Therefore, 180 minus 150 means again it comes sine 30 only. So that's why that value is coming as the same for both. And similarly for 60 and 30 also. Sine 30, if you put 2 theta means 60 degree, sine 60 degree. And if you take 60 degree, it will be 60 into 2, 120. 120 means again sine 180 minus 120. That will be equal to 60 degree itself. So therefore, for 30 and 60 degree also it comes same. And moreover, you can try even for 40 and 50 also. I think it will come almost same. So this is about your theory of your projectile motion, what we can analyze, what we can study, or what are the things we can realize based on the projectile motion. For this, I have put this tabular column with maybe minimum of 6 trials. I want to see all of you are doing and taking readings and entering. So you can have a tabular column like this: trial number, velocity of the projectile, angle of projection in degree, time of flight in seconds, the maximum height, and horizontal range. So these things, time of flight will be given in the simulator itself. Only thing you have to calculate maximum height and range. That maximum height and range you can calculate keeping past the angle same, maybe for 45 degree, but horizontal range is maximum. Keep the angle three trials same, vary the velocity, different three velocities. So first three trials will be with three different velocities. Then the next three more reading tabular column, the columns I have given three more trials. That is different angles, keeping velocity constant. Keep some velocity same. Go for different angles, maybe 30 degree, 45 degree, and 60 degree, so that you can verify that also. Change whether for 30 and 60 will it be same or different value. This is your tabular column, what I have given for you. So this already I have posted in the Google Classroom. It is there. You can download and you can enter the readings in this tabular column. So this says three angles. First angle will be same, three different velocity. First trial maybe 20, third trial 25, then 30 or different values, whatever you want. But theta will be same. Then three more readings, velocity keep constant, angle 30 degree, 45 degree, 60 degree. That is what three. I think somebody asked for some clarification in the chat box. So why do not we take three angles and two velocity? No, this says you have to practice little more. You cannot say, one trial why we have to reduce it. This is for practice. That's all. Not that way. Okay. So 6 trial readings. So if you are tired with that, you can think of 2 or 5. That's not it doesn't make much difference. That too is with your simulator. It is very simple. No need to worry about this. So this is about your theory background, how we can explain the theory background that already you have learned. Sir also taught you in detail about this, how to derive all these equations, everything. It is a repetition for you. After this, we'll go for your experiment. You have to give me 1 minute time. I will stop the sharing this screen. There's all this information already I have posted in the Google Classroom. It is there. You can download. I'll go to this IIT Bombay virtual lab. We'll see this physical sciences. There you click on physical sciences. Then you have virtual astro lab, then molecular lab, solid state, and then many like this. You come to advanced mechanics lab. In the advanced mechanics lab, yes, I will give this. I will click on this. Now I will share. Yes, this is your IIT Bombay where I have gone, and this is our valued Amrita. In this theory, what all we have discussed, everything is given again here. So X displacement, all this are there. What all I have discussed now, everything is given here also. The time of flight, horizontal maximum height, horizontal range, applications, I told you. So even the complex form of projectile application in modern life is a rocket missile, that also rocket or missile. Then sports, all this you can see javelin throw, shot put, disc throw, discus, and then what is this hammer? So many are there, and even this archery as well as shooting. They all follow this one. Then come to your procedure part. You have procedure. You take this procedure itself. Aim is there in the previous slide itself. Here you can see aim to find the time of flight, horizontal range, maximum height of a projectile for different velocity and see angle of projection. And again, if you want this cannon height and environment. Environment is on the Earth's surface. Another one is moon. If you want, you can choose that also. But what we are looking maximum is from you is time of flight that will be displayed. Horizontal range you have to calculate. Then maximum height you have to calculate for different velocity and different angles of projection. That's why I said 3 velocities and 3 angle of projections. That is what you have to go for. So this is the procedure. You can write a little more or less equivalent to this, or slightly modify this and write this procedure, make it some changes for this procedure. So it is given clearly. So select the type of environment that we from the right of the simulator gravity changes. You all familiar. On the surface of the earth it is maximum. As you go to move it changes, becomes that accordingly your all the other values also changes. That also if you want you can verify. So first thing what you have to do is in the variable region is to calculate this time of flight, maximum height, horizontal range. Choose the environment that we will choose on the surface of the earth, and that simulation has to be performed. Then you have velocity slider to help you to fix the velocity of the projectile, whatever the value you want you can fix. Then angle of projection, that also you can have here. First I said first 3 trials you keep angle of projection same, go for different velocities. Then keep the velocity constant 3 more trials and go for different angles. That is what we have to do. So I think that is your things and measurements. Time shows the time of flight of the projectile. Height shows the maximum height of the projectile as reached. Then horizontal range shows maximum distance of the projectile as moved. So these are the simple experiments what you have, simple, and you can do it very easily without any difficulty, without any risk also. So very simple, go fast your simulation part. Simulation you have to login means that you can do, or directly also sometimes if you already registered you can get it, otherwise you can log in and see. So here you can see in the variables you have Earth as well as Moon, Uranus, Saturn, Jupiter. So we choose only Earth. That is fine. If you are interested to do on other surfaces you can. Then velocity you can choose, it shows minimum is 35 and 40, 45. These 3 values you can do, or you can choose any values between 35 to 45. So this is your velocity range. We can vary the velocity of the projectile from 35 to 45 degrees. Maybe I will keep in between to demonstrate for you. Let me keep it at 40 meter per second. Acceleration due to gravity on the surface of the earth 9.8 meter per second square. Angle of projection, as I told you, for maximum it is 45 degree. I will vary this angle of projection and keep it at 45 degree. I kept it. Then this cannon height they have given. You can vary this also from 0 to 40. Let me keep it somewhere around 10. That's enough for me. That you can keep it throughout. If you want, you can constant, or if you want to vary, you can vary for different values. Now I will go for firing this. You can see how nicely it comes. So the projection you can see now. I will fire this. If you click on fire thing, see how nicely it is going up. Maximum I said it is arranged for 45 degree. So you got your time display. This is your time of flight. This is 4.86 seconds. I think this is your seconds, milliseconds, minutes is that you can see if you go for maximum this projection of higher values of angle, that time will be more. If you go for smaller angles of projection, the time of flight will be less. So that means if you go for higher angles, the projectile or an object which is thrown into space, which remains for a longer time in space. That is your time of flight is indicated here. So this is the one. So 45-degree maximum. And then if you want to keep that velocity same, I will show you velocity at what we have chosen now. It is 40. I will make it 30. So 30, if you keep velocity, you will see now angle of projection. Okay, different angle of projection. 30. Let me try. Velocity will be same. You can saw 30. If you erase this, it will go. If you want to keep this, just I will keep it as such and I will fire again. You can see the path of the projectile for 30 degree also. After that, we will erase. So you can see the projection of this for 30 degrees also. 40 degree, 45 it is maximum, 30 it has come down. If you want 60, you try, it will come back again. If you want for 60, you try and see, it will be more or less 30 or slightly, there may be a small variation. Velocity I will keep same and then I will fire this. It will go, our time will be taken more compared to your, I think 3 point something it has taken for your 30 degree or 60 degree. It is more time, that is 5.868 seconds it has taken. This is how you can, if you want to erase, you can click on erase, it will go. So the Canon height is this height. This also, if you want, you can see how it varies. I can now I have kept at 10. If you want, you can keep it at 0. You can see, or if you want, you can keep it at 20. That also you can see. The height is keep varying here. So this is your experiment. This is what you have to do, and you have to tabulate your readings and then calculate time of flight. Here itself, the display shows. Only thing you have to calculate using velocity value and angle value, angle of projection, maximum height, horizontal range, time of flight. It is shown here itself. So this is your experiment, simple experiment, easy to do. You can perform the experiment and you can note down all the readings, tabulate, and you can enter. Simple experiment. Any doubts if you are, you can ask me now. Sir, you want to add something? Ravi sir?
Yes, sir. I think everything is explained. Students, you can just use your discretion to verify some of the other parameters, something like maximum height and a maximum range and all. At what two angles you will have the same range, right? You can decide, and accordingly it's a complementary angle. So theta dash is equal to 90 minus theta. So that angle you can fix for different angles. It need not be 30-60 or 45-45 or 20-70. Some other angle also you can just find out, and you can verify the complementary angle, that principle also. Then maximum range, what angle you get maximum range by keeping the velocity constant also you can find out. So someone was asking in the beginning whether we have to do only 5 experiments, 5 trials or 6 trials. You can do any number of trials. I just ask you to do around some 20 trials, right? By adjusting the velocity and the angle, you will be able to perform many things, and you will be able to verify the laws which were studied earlier, or the complementary angles can be verified. All those things can be found. And one more thing in this simulation, anyway, you have to check it out because I've not performed the experiment. They have given the height of the cannon. Height of the cannon.
Yeah, that is where the projectile is coming out of this gun. That height only. This we can vary. See this, you can see now it varies. Now I kept at 10 meter. It will reduce. You can reduce it. Blue line it shows. Now I kept at 10. 0 means that exactly comes to that red line itself. If you go to 20, it will keep, see the blue line, it indicates the height from the point where this bullet, or what you say, the object which is thrown, that height only it is. That you can vary, that is not required actually. If you want, you even keep it at 10, otherwise 0 also fine. There is no problem with that. Anything is fine for that. If they can keep at constant 0 itself. Or for they can repeat that also varying some trials.
Students can use your discretion to study the position of the cannon, right? If you increase this one, I do not know how they have done the simulation here, whether they take the range, whether this is fired, the velocity is calculated from the nozzle of the cannon, I do not know, or it is calculated from the bottom. That we have to check it, right? Only by performing the experiment, you'll be able to check this. If it is coming from the nozzle, if the velocity, the projection velocity is considered from the nozzle, then the distance will be changing, because with the same plane only, now that formula is suitable.
Yes.
Otherwise, the initial velocity should be changed. Anyway, you can all of you can apply your mind to study this one, right? It's a good experiment. The cannon has been now it is raised to a certain position. From there, we find. So that
Yeah, I kept it earlier 10, now it is at 0.
From that plane, it is covering, it will cover a little more extra distance down, right? So anyway,
now we'll see this we can try also. Angle of projection, I'll keep it 45. You can fire and see what will be the from 0. This is the one. Next, if you want, you can keep it at 10 and
20 you keep it. 20 you keep, and now you fire with the same velocity.
Yeah.
Same angle, same velocity.
That also we can try. Now we can again once more. Same velocity. But yeah, if you increase the height, that goes to longer range.
This is what I told you. Anyway, the students study this one by performing many such experiments, try to come out of the concept, right, by raising the height. So why there is a change here in the which one in the range? The horizontal range, if you take from the red line, that is the ground line, it will be changing. But the blue line above, the gray line is there above, that will be same, whether it is below or above. If it is taken in the same plane, the range is the same. But if you take from the ground level to that position, there will be an extra distance. You can just apply your mind, try understanding the concept of it. So this is used, I don't think this principle is used for the missiles. It is only for the projectile. Missile cannot be called as a projectile because the velocity can be altered because that there you apply rocket principle, but this is not the rocket principle. So only projectiles can be used here. Missile may not come under this projectile because the projectile
targets, short range targets, they may use this.
In the case of projectile, initially you are giving initial velocity. That's all, right? You don't give anything more than that. But in the case of missiles, you keep giving during its path, right? You can adjust any velocity, direction, anything can be done by using the missiles. You would have heard about the intercontinental ballistic missiles and all those things. Fine, that principle, rocket principles are different. This is a projectile, just thrown with the initial velocity, and it obeys all these things. Anyway, students have to study right, for different angles and different positions, try to get the essence of the experiment. That's very important. So you can perform probably about some 20 different trials you can take. All simple, right? By changing the angles, you can verify the complementary angles also. By changing the cannon's height, you can do, and the initial velocity also you can change. And you try changing with the 90-degree angle also. 90-degree projection is there. Is there. Try with this one. It will shoot straight up. Overhead position, it will go and then come down. That is the maximum height that you will get in any of the angles. And the maximum range, if it is projected with 0 degree, right? You get
90, you can see like this.
yes.
Yes. Goes up, comes down with the same initial.
Yes, like that, you can study. And cricket players and all, they're hitting the ball right with a certain angle, right? What with what angle, it will reach the maximum range. That also you can calculate by analyzing the formula. You'll just get to know around 45 degree. If you keep, it will cover maximum range. Right, all those things, you will be able to understand, grasp. That's what the experiment means to you.
Maybe they want to hit the sixes maximum range. They can calculate based on this and then hit.
Okay. Let them try. All of you can take about 20 trials, minimum 20 trials. If you have done more number of trials, I can presume I can understand that, right, you have studied the experiment properly. Any other doubt you can ask now?
They already learned in theory as well as PUC it was there. Now they are learning in BSc also. They are well familiar with this, I think.
Niket was Chatterjee was asking this question: can't we just to keep the cannon height at 0? If it is 0, you don't study the cannon's height with time of flight or range or anything, right? You have to study that also. Yes, you can write the height of the cannon also in the tabular column. Yes, you mentioned that also. Yes, that's right. That can be added to the tabular column. Any other doubt you can ask us. Otherwise, the experiment is very fine. The experiment is a simple experiment, but you can have a very good understanding, right? Mainly by verifying this complementary angle here, maximum range and maximum height, all those things can be done. With respect to cannon's height also, you can study. These are the things you're expected to learn from this experiment. You need to calculate error for time. Time is recorded from this from the timer given in the simulation. I think you can try with your cell phone timer also. You can use stopwatch. You can use. You can check whether that time is matching with this time. It should match.
Somebody asked, so red line implies that it is in the ground. Yes, that is surface level.
One of the question Bhargavi has asked, do we have to write the observation for 20 trials? Yes, you need to write the observation. If you perform the experiment, you need to write those things. It would take longer time.
We have to prepare for midsum as well. That is their worry.
Hmm. Error percentage calculation, how are you going to do it? Tell me, one of the students can explain. With respect to what, you'll find the error. Ashoka, when are you expecting them to submit?
Yes, maybe next after the midsum exam.
You have
Let them
plenty.
practice. After the midsum exam, they can submit.
Yes, you have plenty of time. There is no time restriction here. Even that would not have been mentioned in the timeline also. So no deadline. So probably before the your next which class practical class you can submit after the mid semester exam.
But you should not leave it as such. You have to complete it.
I think you can perform the experiment today tonight itself, and then you can write a submit or record tomorrow day after. It's not a big experiment.
Simple experiment, not much. Only simple calculation. No
Calculation.
graph, nothing.
Using formula, we can theoretically find, sir. You are finding it theoretically only. You are calculating from the simulation, you are finding time, right? That time you are putting in that formula, and from there you are calculating. That's all. For time observed and calculated value error can be found. The observed calculated value of time. What do you mean by calculated value of time? Is the observed value what is being given here in the timer? Calculated value of time is what?
They may be keeping another stopwatch, and the moment they fire, they can start and see. That way is idea maybe.
So one of the question has been asked, what do you mean by range? Is it the distance from the initial point to the red line or blue line including the cannon's height?
No, range is the maximum distance covered by the projectile from the point of projection to where it go and falls on the horizontal surface. It is a distance from the point of projection to where it falls on the horizontal surface.
It is the distance covered by the projectile along the
Horizontal direction,
x-axis
x-axis,
in the same plane.
same plane from the point of projection.
Shruti Agarwal has asked 2u sin theta.
By G
Yeah,
cannot
there's a
we
formula.
use this formula.
Yeah, they're using that formula only, right? The time of flight.
This is shown here. They are not calculating. This is shown in the clock. Here, they have given. This is the time shown is time of flight.
Like that. Okay, okay. So they just want to know whether
Yeah, this and what they have shown and what they calculate from theory. That equation T time of flight is equal to 2u sin theta by G. Whether it comes same or not. That you can yes. That also if you want you can check. First check.
correct. So now you can do, yes, I got it now. I thought only time you are putting in some other thing. Right, you are calculating the time here, and this time is observed time. You are doing the calculation separately. That's a calculate time. That question was right, and somebody else also, Jason was asking this question. Correct. That is the calculated value. This is the observed value. Finally, you can match now whether both of them are matching. Should match.
Sir, both of them will not match if the cannon height is more than 0, right?
Perfectly right. So That's what I had a doubt in the simulation whether they corrected that one or not. The equation holds good only when it is in the same horizontal plane, right?
Cannon height should be 0.
The range, I don't know that you have to check it inside. No, you have to check whether even if you raise the cannon, whether the initial velocity is taken. I do not know how the timer is.
Race depends as in the simulator part. We have only we kept the constant velocity, same velocity, but see here we are varying the height. Cannon height, the range also different. That means definitely time of flight also will be slightly different. It will be different.
No, whether this one simulator counts this time, right? When it reaches the same plane, whether it is counting this, that I don't want to know.
That takes a little more time. Definitely, range is more. Time also will be more.
Now, once more, you can just fire it. Keep the height of the cannon. Let that be in the same position.
Okay.
You fire now. Let us see the time again.
Okay.
And I'm not
This
there.
is 90. Okay. Let me change it.
Keep it in some other position. Let us say 50 degrees something.
Last time I think we tried for 40. Let me try now 50 degree.
50 you keep and then fire. Let's check. You look at the timer also, whether it is crossing this point or that point.
It's slightly less now.
No. Now the timer, no, it recorded the time as it crossed that horizontal plane or a down part, ground.
No, when it touches the ground, it notes down time from the point of firing to touch the ground.
So once more you fire, let's see.
If the other things you want, or we erase that?
I erase this and then you fire now. And it comes.
4. This is 5.478. That much is the time of flight.
Once more.
And we'll keep this, say 5.478. This is keeping at 20. If we keep it at 0, we'll see. If you keep at 0, cannon height and then 5, we'll see. That is 5.478. If this takes less time, since height is reduced, time also less. If you increase the height, the cannon height, time also will be more. Horizontal range also more.
This range is short and that range is more.
Yes.
So that may be the velocity, the nozzle velocity may be the velocity on the ground. But now the cannon's nozzle velocity may be the velocity when it is placed, if it is placed on the ground. Oh, right. Maybe that way they would have done the simulation part. Let them perform the experiment and check for different heights. Yes.
As you increase the cannon height, range is increasing, time is also more. If you decrease to 0, range also less, time is also less. Previous one 5.47. Now it is 4.97.
No, this is
0.
This is something like I go to the top floor and throw a body, right?
Yes, yeah, that is how.
It will cover
floor, maybe first floor, second floor, like that.
It will cover more distance, yes. Okay.
So range is the distance, maximum distance in the same plane, right?
Yes.
But if the cannon height is raised, the plane is also getting shifted up. So that's why the range is getting more.
That is what, and I do not know whether this being the simulator, it has been given like right on the same plane, or whether they have taken the velocity from the nozzle of the cannon, or the velocity is taken from the ground. That I do not know how they made it how they programmed in the simulator.
So if we can see the path, right? So it's from the ground only, I think.
From the ground, you say?
Yes, sir.
For that you have to what you have to do is you have to study, you have to perform 2-3 experiment trials, and then you study from that. Good. You can come to a very assertive conclusion.
Yes, sir. But because if when the cannon height is about 10, then the range that we get from the experiment will not be equal to the calculated range, right?
Check. You study. It is left to you. Use your discretion, right? have a scientific temper of mind and study all those.
Then, sir, can I add more columns in the observation too?
Right, it's up to you, right?
I mean, not the number
Anything
of
what you
units,
have
I
to
mean
write,
more
we have
columns.
given. If you want to try for maximum, more number, more trials, more possibilities, you can always. You are welcome.
Okay, sir.
All that you need is a scientific bent of mind to study these things. They would have given certain things, you can extend your ideas. That's how you gain more knowledge. Check, study, Jason. Again, you check and study, perform some 2-3 trials and then study. You have enough time, about 2-3 weeks to submit the record. Okay, I'll read out the absentees. Ashok sir.
Yes, sir. ಅದು ಆನ್ಲೈನ್ ಸಬ್ಮಿಟ್ ಮಾಡ್ಬಿಡಿ ಸರ್. ಮತ್ತೆ ಮೇಲ್ ಕಳ್ಸೋದು ಬೇಡ. Now itself you can submit by mobile.
What
Now
is
itself.
it?
Through mobile itself you take attendance and submit now online.
Yeah. And that's how I'm doing. No problem. I'm doing it. So now I want to read out the absentees.
Okay.
These are the numbers who are absent for the class from PME.
Okay. I will note down.
No, you don't have to note down. Then this I'm informing for the students.
Okay.
Not to you. So 308 is absent. 321 is absent. 330 is absent. 334 is absent. 355. These students are absent from PME. Then from PCM, 408, 410, 411, 419, and 460.
Now totally there are 124 participants. Now 123, one more person has left. That means V3, 120 people are there. Sir, you said 116 or something regular, but today it is 121.
No, this I do not know because they would have joined with the 2 laptops or something.
Oh, another one, Pushkar Singh, his name is coming, but his register number is not there.
Yes, done.
Okay.
Says Sairaj Natraj, can you repeat me the PME absentees? PME 8, 21, 30, 34, and 55. Okay, I'm just going to, I'll enter it in the KP.